Hey guys, Ms. Gosling here with another video on solving projectile motion problems. For this video, we are going to be looking at what happens to a projectile in the y direction, and to do that, I'm going to go ahead and work through this example problem. A cannonball is launched with an initial velocity of 20 meters per second at a 45-degree angle. Find A, the maximum height of the cannonball, and B, the time it takes the cannonball to reach this height. So, I'm going to start, as always, by drawing a picture. So here's our cannon and our cannonball. I'm going to go ahead and draw in the flight path of the cannonball. Notice that it is a parabola, as we expect in projectile motion. I'm also going to go ahead and draw in the vector for my initial velocity, u. So here is u, which is 20 meters per second, and our angle, which is 45 degrees. Now, for part A, I want to figure out the maximum height of the cannonball. And then for part B, I want to figure out our time to reach that height. So now I am ready to go ahead, start laying out my knowns and unknowns, and start solving the problem. And to do that, I'm going to go ahead and fill out my SUVAT table. So we have SUVAT. And this is all going to be in the y direction, so I'm going to go ahead and just put in little y's next to each of those. So our s in the y direction is what we're trying to find in part A. And I'm going to go ahead and I am going to actually make that blue. And then we have u in the y direction, and breaking down our vector, we know that the initial velocity in the y direction can be given by the equation 20 sine 45 degrees. At this point, guys, make sure your calculator is in degree mode, because if it is in radian mode, it will mess you up. Now, let's go ahead and continue going through my givens. At this top point here, my velocity in the y direction is 0, because that is the point at which my projectile is stopping for a split second before it changes direction and falls back down to the earth. Additionally, this is the y direction, so our acceleration is, as always, negative 9.8 meters per second squared. Finally, for part B, I want to find the time it takes the cannonball to reach its maximum height, and so I'm going to go ahead and put a question mark there in green. So I have drawn a picture, I've listed my givens and unknowns out, and now I'm ready to solve. So let's go ahead with part A, and I'm going to go ahead and work through that. Now here, the equation that I want to use is going to be the one that doesn't involve time. There's only one equation that doesn't involve time. Hopefully you know this. However, if you don't, the equation that you're going to be using is v squared equals u squared plus 2as. So our final velocity squared is equal to our initial velocity squared plus 2 times acceleration times displacement. I'm going to go ahead and stick in the numbers and solve. So v squared is 0. U squared is 20 sine 45. So u is 20 sine 45, which is approximately 14 meters per second. You are welcome to stick this in your calculator and check that out. But I'm going to go ahead and just put that in. So we've got 14 squared plus 2 times negative 9.8 times my displacement in the y direction, which again is what I'm trying to find. So solving this, I get 14 squared equals 19.6s, or s equals 14 squared over 19.6, which is approximately 10 meters. And there you have it, guys. I have solved for my maximum height. Now, I'm ready to solve for my time to reach that maximum height. So figure out part B. So part B. And to do that, I am going to use the equation that doesn't involve displacement. Now, because I have solved for displacement, I could use any of the equations that I wanted, but in case I made a mistake solving part A, I want to use an equation that doesn't rely on that answer in order to prevent myself from continuing to carry forward any errors. So, the equation I'm going to use is V equals U plus AT, where V is my final velocity, U is my initial velocity, A is my acceleration, and t is my time to reach that final velocity. So again, I'm going to go ahead and plug in my numbers from my SUVOT table, and I get 0 equals 14 minus 9.8t, which gives me t is equal to 1.4 seconds. And there you have it, folks. You now know how to figure out the maximum height of a projectile and the time it will take that cannonball to reach its maximum height. My question for you, how long is the cannonball in the air? Try to figure it out. Pause the video, think. Okay, so hopefully you've paused and come back. And what you will find, or what I hope you figured out, was that the airtime is equal to 2 times the time to reach maximum height. So I'm going to call that 2 times ty. Or in our case, our airtime, which I'm going to call t-air, is 2.8 seconds. If you are not sure why that is, please shoot me an email, message me on Remind, or reach out with any other with your questions. I'm happy to explain it to you. Have a wonderful day. Go ahead and try out all of the problems that I've linked. And again, as always, let me know if you have any questions.